Hi, my name is Bernie Broderick, Technical Training Manager for Eastern Acoustic Works, and this is Nathan Butler, Principal Design Engineer here at EAW and the man primarily responsible for the design of the system that we're going to talk to you about today, the KF740.
One of the primary reasons we developed the 740 was to fill the obvious gap that we had between our 760 module and our 730 module. In doing so, we've also allowed the user to use the 740 with either system, either acting as a downfill element with the 760 or as a main module with the 730, where the 730 would act as the downfill module.
Let's face it, production companies are always trying to save money. So are promoters. Trucking is expensive, labor is expensive, and we all need to find ways to make shows more economical. The 760, as good as a system as it is, at times is too large for some types of events, and the 730 ends up being too small for some. The 740 is the perfect enclosure and sits right between the two in terms of performance, weight, and overall value.
Another reason for developing the 740 was to take advantage of everything that we've learned over the past 8 years. Not only the general physics involved with line array theory and line array implementation, but also the processing techniques that we've developed, the tricks that we can do with DSP. The 740 is one of the first systems that we actually designed where focusing was an option from the get-go. So from day one, we really took the advantages of focusing and applied it to not only the transducer design, but also the system design.
EAW has taken another critical step with the approach of the KF740 system. All KF740 systems sold will be packaged with the company's UX8800 digital signal processor. This is for assurance and confidence to the end user that from system to system, performance is going to be consistent worldwide. So, sit back, relax, we're going to take you through the enclosure, explain how everything works, how it rigs, and we hope you enjoy it.
So it's not too often we get to see engineering prototypes here, but this is exactly what we have. This is actually the first prototype system for the KF740. And I'm just going to spend a little bit of time going over some of the inner workings of the KF740 with you. To start off, it's a 90-degree system, 90 degrees horizontal, 12 degrees vertical. We chose that pattern because it kind of fits nicely in between the KF730 and the KF760. Works well as a long throw module, but also as a near field module. The KF740 uses two 62mm compression drivers. Those are 62mm voice coil, 1.4-inch exit. That's an improvement over the 730, which uses two 44mm voice coil and 1-inch exit compression drivers. This provides for much higher output, which is an obvious attribute of the KF740. The two high-frequency devices are separated by this divider, which integrates the two wavefronts better and actually provides for a flatter wavefront, which is something that we're trying to achieve with this line array system. The mid-frequency devices used in the KF740 are 8-inch mid-ranges, 3-inch voice coils. And one of the biggest differences you'll notice from it to the KF730 and the KF760 is the aperture design that we've chosen. For those of you familiar with the AX series or even our own NTL720, you might be familiar with the CSA technology, or Concentric Summation Array. What this essentially means is rather than using a single large aperture for our mid-frequencies, we're actually using several smaller apertures, in this case these diamond shapes, to get that same amount of mid-frequency energy into the common high-frequency, mid-frequency horn. What this actually allows for is an improvement in the high-frequency transient response, because the high-frequency wavefront that's traveling through this horn sees a much more solid horn wall at any given point along the path of that horn. So rather than seeing a single large opening, that high-frequency wavefront sees about a 20% opening, rather than 80% or 100%. And what this allows for is much less high-frequency energy to enter into that mid-frequency void and then reflect out late, vastly improving the overall transient response of the high frequencies. So like the KF730, the KF740 uses a pair of side-firing 10-inch woofers, but also adds a pair of front-firing 10-inch woofers. Like the 730, the side-firing woofers allow those devices to be spaced as far apart as physically possible, given an enclosure this size. What that allows us to do is extend the 90-degree pattern control to a much lower frequency than would be otherwise possible if we only had devices mounted in the front. The addition of the 10-inch woofers in the front not only provides for about 6 dB of additional output, it also allows for much more of that load to be forward firing than rear firing.